All right, the next question is, a function is defined by f of x equals this, where a, b, and n are constant values. Show the gradient of the tangent to this curve at point x equals 0 is that. Okay, so the gradient, all right? So that means we just have to figure out the derivative and then just plug in 0, then we are expected to get this one, right?
So it's basically just testing how well you actually know how to differentiate.
How well you know how to differentiate with all these unknown variables.
Yeah.
Okay, so that if it was just like, f of x is equal to, so for example, like 3x plus 1 to the power of 5 and then x plus 1. Do you know how to differentiate? Yes, I do. So you just got to do 5 bracket 3x plus 1 to the power of 4 times by 3 bracket x plus 1 plus, I'm just using the product rule. And then you just got to differentiate that times by this. So it's just going to be 3x plus 1 to the power of 5. And then you just have to plug in 0. Then you can get the answer, right? So it's just going to be 5 times 3 times 1. If you plug in 0, 0 there, plus it'll be 1. So it'll be just, 16. But it's pretty much the same thing, except that you don't know these values. So you have to differentiate with all these unknowns, which is of course more difficult than dealing with numbers. And you just have to plug in 0 there. So f of x equals to ax plus b to the power of n, and then x plus 1. Now, if you have u, that's equal to ax plus b to the power of n. So u dash is equal to n bracket ax plus b to the power of how much?
N minus 1.
N minus 1. And then you got to times by?
A.
Differentiation of the bracket, which is a, right?
Yeah.
So if you simplify it, it's an bracket ax plus b to the power of n minus 1. Now you got to do v as well. V is x plus 1, right? You don't need any bracket, so it's just x plus 1. And then v dash is equal to just 1, right? So now time to do the f dash of x. So that's equal to that one times by that one. So it's a, and I'm going to write that bit first. Of course, you got to protect it with a bracket because it's now being multiplied by a bunch of other things.
Yeah.
So that is the multiplication of that and that, right? Plus that one times by that one, which is ax plus b to the power of n, true?
And then
now, of course, we can plug in 0 here and see what we get, right?
Would it be safer to move the ax plus b to the n minus 1 down and create a fraction?
Oh, you don't have to move this down because we don't know whether this is a negative number or not. If it was ax plus b to the power of negative 2, then of course it'll be, that. But then if you want to move
but I mean because there are two
ax plus b,
lots of ax plus b, and then there's n and there's n
I'll show you later how to do it, okay? But anyway, if you want to move it down, then if you move it down, then what happens? What's going to be the exponent? It'll be 1 minus n.
Okay.
Negative 2 is to 2 the way negative n minus 1 is to 1 minus n. Okay?
I see.
Because like n minus 1, if you take the negative sign, the opposite of it, then you get 1 minus n, right? So anyway, so there's no reason to move this one down. Okay? It's going to make things a lot more complicated.
Okay.
I think it's if you don't know how to simplify this, it's time to, because the differentiation is now done, you could just plug in 0 there, right? It'll be an 1 b to the power of n minus 1 plus b to the power of n, true? And then of course there's no need for bracket there, so this will be an b n minus 1 plus b n, true?
Yeah.
Now it's time to look at the answer. Oh, so we need to get that. That's the goal. That's what we need to get. So that means we need to pull out Bn, true?
Yeah.
If we pull out Bn, then this will be just 1 here, right?
Mm-hmm.
But then, like, what's going to be left over here? This will be An. I want you to think about this for now, okay? If you have x squared plus x cubed, you pull out how much?
X squared.
Then you're left with
1 plus x.
right?
Mm-hmm.
However, if you pull out x3, then this will be 1 plus 1 over x. Is that right?
I presume so. I haven't done that before.
Yeah, this is pretty difficult stuff. Okay. So if you pull out more than what you have.
Because it's to the negative, it'll be to the -1 if it was.
Yeah.
I don't like that.
So this is the kind of technique they're using here. You have Bn minus 1 and Bn, but they're pulling out something that's more than this one. See? It's as if you have AnB2 plus B3, but then if you pull out B3, then what do you get? You have An over B plus 1.
Plus 1. Yeah.
So that's why you get B over here.
Okay.
So that when you, what's Bn over B? That's the same as Bn minus 1, right? Which is this one here. So you times that one by that one.
Mm-hmm.
Then you get Bn minus 1. And then you have Bn, and then this is an An over B plus B over B. One is the same as B over B. So you get the Bn. And this is an An plus B over B, which is the answer over here. Okay.
I see.
So now, this is recommended for people who cannot factorize this one here. So now let's factorize this one here, okay? So if you've got An x plus 1 and then Ax plus B n minus 1, there's a choice. You can either pull out Ax plus B to the power n minus 1.
Mm-hmm.
Then you get An x plus 1, An x plus 1. And then you have Ax plus B, you know?
Mm-hmm.
So you get one of this left, see? The other choice is if you pull out Ax plus B to the power of n, which is pulling out more than what you have there, then you're going to end up with a fraction, right?
Mm-hmm.
So if you pull out, you're going to get 1 here, right?
Mm-hmm.
But then you're going to have what? An x plus 1 over Ax plus B. Sure.
Yeah, I found when I was doing the product rule and having to factorize stuff like that, I found it infinitely easier to take out a fraction.
Yeah.
Although that said, I hadn't been working with
Anyway.
Yeah.
So, but of course, there's no need to do all this stuff because when you plug in, as soon as you plug in 0, it simplifies this whole thing a lot. So it's a lot easier to deal with this stuff. But if you still want to know how to do this stuff over here, then yeah, then why not? So this one over here, that becomes Ax plus B to the power of n bracket An x plus 1 over Ax plus B plus Ax plus B over Ax plus B. Then it becomes, just for the sake of, practicing simplification, because, for anyone taking calculus seriously, they expected to know how to simplify things, So this is Anx plus Ax plus An plus B. So if you just expand it all out, you get this one here. Right? And then if you plug in 0, then you get, of course, f of 0 dash, then Bn. This will be just B over here, 0, 0. So it'll be just An plus B, which is exactly the same answer as this one over here, right? This one.
Yeah.
Yeah. All good?
Yeah, I think